Welcome everyone to my channel, which is Pharmacoach. And in today's Pharmacoach class, we will be discussing about the different terms used in biopharmaceutics. So number one, we have the pharmacokinetic. And it is the study of time course a drug takes in moving throughout the body in performing absorption, distribution, metabolism, and elimination. That means pharmacokinetic is nothing but study of the time course taken by the drug by doing different processes like absorption, distribution, metabolism, and elimination. In other words, we can say that it is the explanation of body processes like absorption, distribution, metabolism, and elimination, and determining how much time a drug takes in completion of such processes. Another definition we have like pharmacokinetic is the study of how body deals with the drug, mean body's effect on drug. And PK determination helps in clinical settings to enhance safe and effective therapeutic management of individualized patient. For example, a person with kidney and liver disorder shall have disturbed PK processes such as drug elimination, drug metabolism. In such condition, the patient may have increased drug residence time or drug half-life time in the body, and patient may develop drug toxicity due to damaged organs. Hence, such patient require dose adjustment. इसका मतलब ये है कि जिन पेशेंट को किडनी और लिवर का प्रॉब्लम होता है उन पेशेंट में मेटाबॉलिज्म और एलिमिनेशन प्रोसेस डिस्टर्ब होते हैं. एज अ रिजल्ट ड्रग रेजिडेंस टाइम और हाफ लाइफ टाइम इंक्रीज हो जाता है. एज अ रिजल्ट ड्रग टॉक्सिसिटी हो जाती है. देयरफॉर वी नीड सम डोज एडजस्टमेंट एंड PK understanding is important parameter in developing safe dosage regimen. मतलब PK की मदद से हम safe dosage regimen भी सेट कर सकते हैं. Intravenous drug directly enter into the blood and doesn't require absorption. Therefore, they are having 100% bioavailability and this is known as absolute bioavailability. IV drugs की 100% bioavailability होती है. क्यों? क्योंकि ये absorption process को bypass करती हैं और directly enter होती हैं into the blood. Oral drugs require absorption and first pass metabolism before entering into systemic circulation. Hence, they have altered bioavailability known as relative bioavailability. इसका मतलब ये है कि जो ड्रग्स हम ओरल रूट से देते हैं उनकी बायोअवेलेबिलिटी रिलेटिव होती है, मीन्स लेस देन एब्सोल्यूट बायोअवेलेबिलिटी, because they require absorption and first pass metabolism before entering into systemic circulation. And the drugs after entering into systemic circulation in the blood may exist in two forms, may be bound or unbound form, means inactive or active form, or free or in bound form. अच्छा जी, ड्रग सिस्टमिक सर्कुलेशन या ब्लड में आने के बाद टू फॉर्म में एग्जिस्ट करती है जो कि एक्टिव और इनएक्टिव हैं. अगर ड्रग फ्री फॉर्म में है तो ये एक्टिव फॉर्म है और अगर ड्रग बाउंड फॉर्म में है तो ये इनएक्टिव है. एंड bound drug mostly bind with plasma protein which is temporary and reversible. It may be because of the covalent bond. And drug may be bind with plasma protein albumin or the alpha-1 acid glycoprotein in the blood. And bound drug cannot cross blood capillaries. Therefore, it is less distributed and unable to bind with receptor on cells. Hence, in such a state, drug don't produce pharmacological effect. Whereas free drugs can cross membrane and capillaries, hence distribute easily and produce their pharmacological effect. Now, what is absorption? It is process of reaching of drug substance in the systemic circulation. It is the process of passing of drug from extravascular areas of body, means skin or GI tract, into systemic circulation of blood is called absorption. In other words, we can say that absorption is the movement of drug from the extravascular areas of body or the site of administration into the blood. Drug concentration after absorption rises into blood and reaches up to certain level. These are called level of drug concentration in blood. Levels include like MEC, MTC and intermediate or therapeutic level. Now, what is pharmacokinetic distribution? It is the process of drug after absorption, which is movement of drug molecules away from blood compartment into tissues, cells or receptor sites. Or in other words, distribution is nothing but the movement of drug molecules from the blood into tissues, cells or receptor sites. And in this process, drug has to leave blood and transfer into deeper levels of tissues and cells to show the pharmacological effect. फार्माकोलॉजिकल इफेक्ट प्रोड्यूस करने के लिए ड्रग का सेल्स तक आना बहुत ज़रूरी है. Drug distribution may occur up to organ level, also depending upon the blood flow to that organ. For example, in the heart, liver, brain, lungs, kidney, sex organ, and to produce the organ-based effect. Distribution of drug blood flow पे भी depend करती है. For example, जिन organs में blood flow ज़्यादा होगा तो उन organs में distribution of drug पहले होगी. Now the pharmacokinetic elimination. Faster the elimination, less will be the concentration of drug in the body and shorter will be the effect of drug. And faster the elimination, less will be half-life time of the. इसका मतलब ये है कि elimination और half-life time ये दोनों inversely proportional होते हैं. That means slower the elimination, more will be concentration of drug in the body and longer will be the effect of drug. Slower the elimination, more will be the half-life time of a drug and half-life time of a drug and elimination are inversely proportional to each other as I told you before. Now the pharmacokinetic drug disposition. So this concept is related to overall determination of time course, means how much time a drug takes in performing distribution and elimination. Drugs that under metabolism for excretion are also included. Hence, sometime distribution, elimination and metabolism are considered. इसका मतलब ये है कि drug distribution में हम time course को study करते हैं, which is taken by the processes like distribution, elimination and metabolism. Now the biopharmaceutic terminologies. Number 1, we have biophase. It is the actual site of drug action in the body where drug receptor interaction happens and drug produce its effect. Biophase may be surface of cell or within the cell. In other words, biophase को हम active site भी कहते हैं या receptor site भी कहते हैं और ये within the cell और surface of the cell भी होती है. यहाँ पे drugs bind होती हैं to produce the pharmacological effect. Now the plasma time curve. Plasma time curve obtained from blood samples by manufacturer in certain time intervals after administration of drug product or microbiological analysis of drug in body fluids. This curve shows drug concentration in plasma versus time collected after intervals of time. Means इसमें हम plasma concentration of drug find करते हैं after certain interval of time. It indicates level of drug in plasma and extent of absorption of drug in plasma. Means lower the plasma concentration, lower might be the absorption and vice versa. Plasma concentration drug versus time may be useful in understanding in vivo dissolution and absorption of drug profile. That means more plasma concentration of drug will show more absorption. या फिर ये in vivo dissolution or absorption of drug profile को फाइंड करने के लिए भी यूजफुल होती है. Now what is MEC? Mean minimum effective concentration. It is the minimum amount of drug needed at receptor to produce the desired pharmacological effect. मतलब minimum amount of drug हमें require होती है at the receptor to produce the desired pharmacological or therapeutic effect. Now what is MTC, which is minimum toxic concentration? Means concentration of drug which shows the toxic effect. Now what is onset of time? So time required by drug to reach at MEC is called onset of drug. So what is duration of action? So it is the difference between onset time and the time for drug to decline back to the MEC. Now the time of peak plasma level. The time of maximum drug concentration in plasma and it is proportional to the absorption and it is denoted as Tmax. Now the peak plasma level. So it is the maximum drug concentration in plasma usually related to dose and rate constant of absorption and elimination. It is denoted as Cmax. Now what is area under curve? So it determined the unchanged amount of drug that reaches to the systemic circulation. It is determinant of relative bioavailability. Now the Cmax. So the maximum concentration of drug that is observed in plasma is called Cmax. Cmax is determination of drug absorption and drug release pattern from its dosage form. Smaller Cmax indicates poor drug absorption or slow drug release pattern from a dosage form. Now the nomenclature of drug. A drug can be called or named by three different ways. Number one, we have the chemical name. An organic compound is represented by an empirical formula. For example, we have given here the formula of the amoxicillin, which indicates the number and relationship of atoms in the molecule. Then we have the generic name. जेनरिक नेम को सिस्टमिक नेम या नॉन प्रोप्राइटरी नेम भी कहा जाता है. फॉर एग्जाम्पल वी हैव the amoxicillin, which is the generic name. Then we have the brand name. So this is the trade name that is given by manufacturer or the sponsor proprietary name. Example, Panadol and Calpol for paracetamol. Brand drugs are also known as RLD, means reference listed drug. Generic product is patented one which can be only manufactured by authorized person, and brand can be manufactured by more than one companies. Now what is bioequivalent? Two drug product having same bioavailability and drug product may be same. For example, same active plus means the same active and excipients and dosage form, or different drug product means same active and different excipients. Then we have the therapeutic equivalent, means when they have same clinical efficacy and safety profile under similar experimental conditions. They are pharmaceutical equivalent. And what is pharmaceutical equivalent? Two drugs having same active ingredient and excipients, means salt, etc., in identical dosage form, use the same route of administration and have different strength. Now the pharmaceutical alternative. Two drugs product having same active or different excipients, means excipients may be salt or complexes. Example, tetracycline phosphate in place of tetracycline hydrochloride. Now the therapeutic alternative. When drug product have different active ingredient but same therapeutic class indicated or same effect. Example, ibuprofen instead of aspirin. Now the generic alternatives. So these are pharmaceutical equivalent made by different manufacturer. So pharmaceutical alternative में हमारे पास same active ingredient होता है और different excipients होते हैं. For example, we have tetracycline phosphate and tetracycline hydrochloride. So यहाँ पे हमारा active जो tetracycline है वो same है और जो उसमें excipients है like phosphate और hydrochloride. So these are different. जबकि थेरेप्यूटिक अल्टरनेटिव में हमारे पास जो हैं वो डिफरेंट एक्टिव इंग्रेडिएंट्स होते हैं और सेम थेरेप्यूटिक क्लास होती है. फॉर एग्जांपल, ibuprofen और aspirin, they both have the same class, which is the NSAID. Or generic alternatives are nothing but the pharmaceutical equivalents which are made by different manufacturer. Now introduction to a drug molecule. So drugs are chemical substances. They are pharmacological active molecule and they have to show or produce desired pharmacological action, which is the therapeutic action. इसका मतलब ये है कि ड्रग मॉलिक्यूल को हम केमिकल सब्सटेंस कहते हैं जो कि फार्माकोलॉजिकल एक्टिव मॉलिक्यूल है. क्यों? क्योंकि ये फार्माकोलॉजिकल एक्शन प्रोड्यूस करती है और इस फार्माकोलॉजिकल एक्शन को डिजायर्ड एक्शन या थेरेप्यूटिक इफेक्ट भी कहते हैं. एंड फार्माकोलॉजिकल एक्शन प्रोड्यूस्ड बाय अ ड्रग डिपेंड अपॉन इट्स कंसंट्रेशन एट साइट ऑफ एक्शन must be available in sufficient quantity or dose to produce its desired or required effect. And to become available at site of action, drug needs to be available, and bioavailability depend upon the physiochemical properties of drug molecule, type of dosage form, and route of drug administration. And physiochemical properties of drug molecule are that which affect on solubility and permeability of drug molecule through the cellular membranes. And these properties include like nature of drug, particle size of drug molecule, log p-value of the drug molecule, or acidic or basic nature of the drug molecule, and pH of the medium. अच्छा जी, तो बायो अवेलेबिलिटी फिजियोकेमिकल प्रॉपर्टीज़ पे डिपेंड करती है और ये फिजियोकेमिकल प्रॉपर्टीज सॉल्युबिलिटी और परमिएबिलिटी पे डिपेंड करती हैं. एंड दीज प्रॉपर्टीज आर लाइक नेचर ऑफ ड्रग, पार्टिकल साइज ऑफ ड्रग, एंड log p value of drug, acidic and basic nature of drug, and pH of the medium. Now the challenges in drug transportation. The body contains many biological barriers. They serve to protect its interior from a variety of external invaders and toxins. The skin is the largest such obstacle, while the blood-brain barrier forms the tightest barrier to penetration of molecule from the bloodstream to the brain. सो हमारी बॉडी में डिफरेंट टाइप के बियोलॉजिकल बैरियर होते हैं टू प्रोटेक्ट अस फ्रॉम एक्सटर्नल इन्वेडर्स एंड द टॉक्सिन्स. इसमें से स्किन जो है वो लार्जेस्ट बैरियर है या ऑप्टिकल है, और इसके बाद हमारे पास ब्लड ब्रेन बैरियर है. Similarly, for a drug molecule to be orally available, it has to transfer the epithelial layer of gastrointestinal tract. And these obstructions to drug delivery can be categorized as physiochemical or biochemical barriers. The physiochemical barrier in the intestinal mucosa or the blood-brain barrier protects the body from various molecules such as toxins by inhibiting their passage through the barriers. Next, the drug must overcome the biochemical barrier, which consists of metabolizing enzymes that can degrade it. Finally, the drug has to have optimal physiochemical properties for its permeation across the biological barriers. Now the physiological barrier to oral delivery. The luminal side of the gastrointestinal tract is covered with an aqueous mucus layer that is secreted by the goblet cells. Before reaching the epithelial layer of the intestinal mucosa, a drug molecule must penetrate this mucosal layer, which has a thickness like it varies from 100 to 150 millimeter. इसका मतलब ये है कि luminal side of gastrointestinal tract वो covered होती है aqueous mucus layer से, और ये mucus layer ये secrete होती है from the goblet cells. इसका मतलब ये है कि luminal side of gastrointestinal tract वो covered होती है aqueous mucosa से, मिस aqueous mucus layer से, और ये mucus secrete होती है from the goblet cells. और ड्रग को इन द epithelial layer तक पहुंचने के लिए has to cross the mucus layer which is having the thickness of 100 to 150 millimeter. This mucus layer acts as a filter for molecule with a molecular mass of 600 to 800 daltons. The mucus is composed of glycoprotein which trap water within this layer with a turnover rate of 12 to 24 hours. The drug penetration through this mucus and unstirred water layer is a rate limiting step before the drug reaches the surface of the enterocytes. Immediately before this layer, on the mucus layer, is a single layer of columnar epithelial cells that are joined together by tight intercellular junctions to form a barrier to the systemic delivery of orally administered drugs. There are 4 regions of gastric epithelium, from the proximal to the distal stomach. So, number 1, we have non-glandular stratified equamous, and then the cardiac, then the glandular proper gastric, which is also known as fundus, and then the pyloric. The toughness of the stratified equamous region allows it to resist food abrasion, while the cardiac region is responsible for the production of mucus and bicarbonate. अच्छा जी, तो कार्डिक एपिथेलियम के 4 regions होते हैं from the proximal to distal stomach. So number 1 we have like non-glandular stratified equamous, and then we have the cardiac, then glandular proper gastric fundus, and then the pyloric. तो जो फर्स्ट रीजन है वो टफनेस प्रोवाइड करता है, जबकि जो सेकंड पोर्शन है जिसको हम कार्डिक कहते हैं वो म्यूकस और बाइकार्बोनेट सिक्रेट करता है. Cyanogen and hydrochloric acids are secreted from the proper gastric region, and pyloric section is associated with the release of the gastrin and pepsinogen. Proper gastric region से pepsinogen और hydrochloric acid secrete होते हैं, जबकि pyloric region से gastrin और pepsinogen secrete होते हैं. Intestinal layer, both villi and crans, are lined by the epithelial cell layer. The microvilli amplify the surface area of the intestine and absorb nutrients and secrete mucus. The crans are responsible for cell renewal. Due to the villi or microvilli, the intestinal surface area is increased. As a result, more absorption of nutrients is there. The epithelial layer is in immediate contact with the lumen of the gastrointestinal tract. The lamina propria, which function as a structural support for the epithelial layer, is situated on the basolateral side of the epithelial layer. The lamina propria contains the lymph vessels, smooth muscle cells, nerves and blood vessels which nourish the epithelium. The muscularis mucosa makes up the deepest layer, which is thought to be involved in contractility. Now the mechanism of transport. So number one, we have the transcellular drug transport. So hydrophobic drugs that can partition through cell membrane are more likely to cross the intestinal mucosa through the transcellular pathway. A drug with the appropriate physiochemical properties or the characteristic can transfer through the cell by passive diffusion. So लिपोफिलिक ड्रग की जो ट्रांसपोर्टेशन होती है वो ट्रांससेलुलर पाथवे से होती है क्योंकि इनमें प्रॉपर फिजियोकेमिकल प्रॉपर्टीज होती हैं. Now the paracellular drug transport. So hydrophilic drugs cannot penetrate the cellular membrane. Therefore they must use the paracellular pathway. So hydrophilic drug जो हैं वो paracellular transport के through transport होती हैं. This physiological barrier is to provide protection from the entry of toxins, bacteria and viruses from the apical side to the basolateral side, and it allows the passage of selective molecules and cells. This pathway is restricted by the presence of tight junction. मतलब कि ये प्रोटेक्शन प्रोवाइड करता है अगेंस्ट द टॉक्सिन्स, बैक्टीरिया एंड वायरसेस और इसमें टाइट जंक्शन भी होते हैं. तो ट्रांसपोर्टर प्रोटीन्स आर एडेनोसिन ट्राइफॉस्फेट डिपेंडेंट पम्प्स व्हिच फैसिलिटेट द इफ्लेक्स ऑफ ड्रग मॉलिक्यूल फ्रॉम द सेल बिकॉज these transmembrane efflux pumps are often found in conjunction with metabolizing enzymes such as cytochrome P450, 3A4, and their net effect is to substantially reduce intracellular drug concentration. Thus, they determine to a large extent the pharmacokinetic disposition and circulating drug concentration of drugs like cyclosporin, nifedipine that are subtract for these proteins. Now, the receptor-mediated transport in which drug can penetrate the intestinal involves receptor-mediated uptake of the drug, and then the carrier-mediated transport. The transport of substance across cell happens with involvement of carrier proteins, and it involves active transport and facilitated diffusion. Now the active transport. The drug move against the direction of concentration gradient, and the process require energy. The carrier may be selective for certain drugs that resemble natural substance or metabolite that are actively transported. So, carrier system may be saturated at high concentration. Now the vascular transport. Vascular transport is the process of engulfing particles or dissolved material by a cell. Vascular transport is the only transport mechanism that doesn't require our drug to be in an aqueous solution to be absorbed. And pinocytosis is the engulfment of small solutes of fluid by cell. And phagocytosis is the engulfment of large particles or macromolecules generally by the macrophages. In simple words, pinocytosis में liquid की engulfment होती है जबकि phagocytosis में solid की engulfment होती है. Now we have the biopharmaceutical consideration via oral route. So gastrointestinal tract has following factors that must be considered in developing an oral dosage form. So number one, we have the pH of media and nature of drug. Then we have GIT motility, then the enzyme availability, and then the absorbing area. Now the gastrointestinal motility and transit time. So small intestine is the major site of drug absorption. So small intestine में सबसे ज़्यादा drug absorption होती है. The time of drug is present in small intestine is extremely significant, and that time is known as transit time of a drug. Decrease in transit time means drug reside for shorter period of time at absorption site and drug become less absorbed. इसका मतलब ये है कि ट्रांजिट टाइम और जो है ड्रग एब्जॉर्प्शन ये दोनों डायरेक्टली प्रोपोर्शनल है. मतलब ज़्यादा ट्रांजिट टाइम होगा तो उसकी एब्जॉर्प्शन भी ज़्यादा होगी. and transit time increase in case of decreased GI motility or constipation or intake of drug that reduce GI motility such as antidiarrheal, parasympatholitics, or the tricyclic antidepressants and the fatty food. So in simple, transit time is inversely proportional to the GIT motility. इसका मतलब ये है कि अगर हम एंटीडायरियल या पैरासिम्पेथोलाइटिक्स या फिर ट्राइसाइक्लिक एंटी डिप्रेसेंट या फैटी फूड अगर हम लेंगे तो हमारी जीआई मोर्टेलिटी डिक्रीज़ हो जाएगी और ट्रांजिट टाइम इंक्रीज़ हो जाएगा. So transit time may decrease due to use of cold beverages, tea, coffee, or drugs that enhance GI motility such as parasympathomimic and एंटी कॉन्स्टिपेशन. इसका मतलब ये है कि अगर हम पैरासिम्पेथोमाइमेटिक या फिर एंटी कॉन्स्टिपेशन ड्रग इस्तेमाल करेंगे तो जो है हमारी जीआई मोटिलिटी वो इन्हांस होगी और ट्रांजिट टाइम डिक्रीज होगा. नाउ द गैस्ट्रिक एम्पटिंग टाइम. So the time a dosage form takes to transfer the stomach is usually termed the gastric residence time and gastric emptying time or the gastric emptying rate. Normally, gastric residence time usually ranges between the 5 minutes and 2 hours, although much longer time over 12 hours had been recorded, particularly for large single unit. So in the fasted state, the electrical activity in the stomach, the interdigestive myoelectric cycle or the migrating myoelectric complex, which is MMC as it is known governs its activity and hence the transit of dosage form. Now, gastric motility during fed state. The proximal stomach relaxes to receive food and gradual contraction of this region move the content distally. Now the peristalsis. So contraction of the distal stomach serves to mix and break down food particles and move them towards the pyloric sphincter. So pyloric sphincter allows liquid and small food particles to empty while other material is retropulsed into the antrum of the stomach and caught up by the next peristaltic wave for further size reduction before emptying. In general, food, particularly fatty food, delays gastric emptying and hence absorption of drug. So this may be an important consideration in terms of the chemical stability of a drug or in achieving drug dissolution or absorption. So ये absorption or dissolution के लिए या chemical stability के लिए very important है. Now the gastric fluid is highly acidic, normally exhibiting a pH within the range of 1 to 3.5. The typical gastric pH values following a meal are in the range of 3 to 7, means after meal it will be 3 to 7 and before that it might be from 1 to 3.5. Whereas the intestinal pH value are higher than the gastric pH value owing to the neutralization of the gastric acid with bicarbonate ions secreted by the pancreas into the small intestine. तो intestine की pH ज़्यादा होती है due to the bicarbonate जो कि secreted होते हैं from the pancreas. So the gastrointestinal pH may influence the absorption of drug in a variety of ways. It may influence the chemical stability of the drug in the lumen, its dissolution or its absorption if the drug is a weak electrolyte. So pH जो है वो important होती है for the absorption, dissolution और chemical stability के लिए. Now the plasma time curve. So dB means drug in body or CP means drug plasma concentration and VD mean volume of distribution are related to each other. So we can calculate each parameter from the values. What is volume of distribution? So volume of distribution is determined from pre-injected dose in the syringe and the plasma drug concentration resulting after dose is injected. So we have the formula like dB is equal to VD into Cp, where VD is equal to dB upon Cp. VD means volume of distribution and dB means drug in body and Cp means plasma drug concentration. So volume of distribution is also calculated from AUC and elimination rate constant. Formula we have VD is equal to dose upon K means elimination rate constant into AUC, mean area under curve. So amount of drug in the body is determined by removing blood sample containing drug at various intervals of time. And VD relates concentration of drug in plasma and amount of drug administered into the body. Following a given dose of a drug, the greater its concentration in various tissue compartments, the smaller its concentration in plasma. Therefore, according to the relationship, dB is equal to VD into Cp, and VD of particular drug will be greater for those drugs that tend to concentrate in tissue as opposed to the प्लाज्मा मतलब dB VD और CP के साथ डायरेक्टली प्रोपोर्शनल है, जबकि VD CP के साथ इनवर्सली प्रोपोर्शनल है और dB के साथ डायरेक्टली प्रोपोर्शनल है. Now the factors on which VD depend. Number one, we have plasma concentration of drug. So smaller the CP, more will be the VD of a drug. Then we have body weight. Fat people have large extracellular body mass, hence have more VD. We have protein binding. So protein bound drugs are not distributed and remain in plasma compartment and hence have less VD. Then we have nature of drugs. So lipophilic drugs cross membrane easily, hence they have large VD. So volume of distribution is VD, and it is given volume of body fluid in which drug resides or drug is available after the administration. Smaller VD determine drug resides in smaller fluid. Example, plasma, protein-bound drug molecule, and large-size drug particles have smaller VD. They are only in blood compartment. Means if drug is more in the plasma, that means drug is less in the tissues. If the drug is more in the tissues, that means drug is less in the plasma. So number 3, we have large VD determine drug reside in larger fluid compartment. Example, drugs that are lipophilic, non-polar, and hydrophobic drugs have larger VD. Then we have number 4, which is intermediate VD. It's two drugs which are hydrophilic and not two protein-bound drugs. Then we have disturbed CP can affect VD. Then we have the loading dose. So loading dose is equal to the VD into Cp upon S into F. So here S is portion of the salt, that is active form of drug, and F is fraction of drug, that is absorbed systematically. And Cp is equal to dose upon VD. Here Cp is determined from the administered dose and its VD. So dose is equal to the Cp into VD. Those can be calculated from the Cp and VD. Now we have the kinetic principle and order of reaction. So number 1, we have enzyme action subtract, then we have the drug bind with receptor, and third we have the metabolizing enzymes act on drug own biomolecule. Number 4, we have the dosage form of drug, DDS release drug content. And number 5, we have transportation. So absorption and distribution of drug happen through the membrane. Then we have the organs such as liver and kidney has to perform metabolism and elimination respectively. These all processes initially happen fastly until they become saturated, means fully occupied. Then their work becomes slow down and independent of substrate concentration. So what is order of reaction? It means speed O, how much time a reaction proceed. O, it is the way how substrate react and interact to produce the effect. Example, how fast water is converted to water vapor means how fast one substance is converted to another substance. So by applying moisture level O, increasing humidity over evaporating water, decrease rate of evaporation because saturation may occur due to humidity. So the formula we have like a rate is equal to the dc upon dt. Now what is zero order reaction? So it is the slow process in which rate of reaction is slow. ये slow process होता है क्योंकि इसमें rate of reaction slow होता है. Saturation of enzyme and mechanism happen. यहाँ पे जो है saturation of enzyme हो जाती है और mechanism की भी saturation हो जाती है. Now rate of reaction is independent of concentration of reactant and rate is constant. यहाँ पे क्या होता है कि rate of reaction independent होता है concentration of reactant के और rate is constant और rate constant होता है means same amount of product will be produced in the same time. Same amount of product produce होता है same time में. So a constant amount of drug shall be absorbed, eliminated, metabolized, transported and distributed in constant period of time. In zero order the slope is straight and follow a non-linear pK because half-life time is not constant, depend upon initial drug concentration. So constant amount of drug जो है वो absorb होती है, metabolize होती है और eliminated होती है और distributed भी होती है in constant period of time. तो ज़ीरो ऑर्डर में जो है स्लोप हमारे पास स्ट्रेट होता है और नॉन लीनियर पीके होती है क्योंकि हाफ लाइफ टाइम इसकी कांस्टेंट नहीं होती है क्योंकि वो डिपेंड करती है इनिशियल ड्रग कंसंट्रेशन पे. So it usually reflects the effect of enzyme or the presence of carrier mediated system. In this situation, the elimination half-life of the drug will increase when doses increase. तो अगेन एलिमिनेशन हाफ लाइफ जो है वो डोज पे डिपेंड कर रही है. नाउ व्हाट इज फर्स्ट ऑर्डर ऑफ रिएक्शन? सो इट इज़ फास्ट प्रोसेस इन विच रेट ऑफ रिएक्शन इज़ फास्ट. ये फास्ट प्रोसेस है क्योंकि इसमें रेट ऑफ रिएक्शन भी फास्ट होता है. नो सैचुरेशन हैपन, इसमें सैचुरेशन नहीं होता. एंड रेट ऑफ रिएक्शन इट डिपेंड अपॉन द कंसंट्रेशन ऑफ रिएक्टेंट एंड रेट इज नॉट कांस्टेंट मीन अनइक्वल अमाउंट ऑफ प्रोडक्ट विल बी प्रोड्यूस इन द सेम टाइम. और रेट कांस्टेंट नहीं होता क्योंकि अनइक्वल अमाउंट ऑफ ड्रग प्रोड्यूस होती है सेम टाइम में. सो अनइक्वल अमाउंट ऑफ ड्रग शैल बी absorbed, eliminated, metabolized or transported, distributed in constant period of time. And it is reciprocal of time means inverse to time reaction and is more in short period of time. In zero order, the slope is not a straight line and follow a linear pK because half-life time doesn't depend upon initial drug concentration and the slope is given by minus k upon 2.303. Now what is half-life time? It is the time or this duration in which half of the substance or the drug is consumed from the total is known as half-life time. And half-life time has unit like hour. So example we have like if drug that is 10 mg absorbed in blood, 5 mg of drug is excreted in 1 hour while 5 mg of drug remain in body. 1 hour is known to be the half-life time of a drug. Based on order of reaction, half-life time of drug varies. So what is zero order half-life time? In zero order rate of reaction, half-life time of drug depend upon initial concentration, hence it is not constant. And the formula we have like 0.5 plus n naught k. और यहाँ पे n naught जो है वो हमारी इनिशियल ड्रग कंसंट्रेशन है. And in a zero order reaction, the elimination half-life time of drug is not constant because it depends upon activity of enzyme or carrier-mediated effect. Hence, it is not linear pK. Most of the drug don't follow zero order elimination kinetic. Now, the first order half-life time. In the first order rate of reaction, half-life time of drug doesn't depend upon initial concentration, hence it is constant, and the formula we have like 0.693 upon k or 0.7 upon k. So here k is elimination rate constant. In a first order reaction, elimination half-life time is constant. It doesn't require enzyme or carrier mediated, hence carrier mediators hence follow linear pK. Most of drug follow first order elimination kinetic. So doubling the drug concentration will not change the rate constant even though the rate of the amount of drug lost in a given time period would increase. How the drug clearance? So human body is considered as a single like tank full of body fluids and drug is uniformly distributed in that tank. After drug administration, clearance is the volume fluid with a concentration of drug is cleared or removed from that tank per unit time. So volume of fluid which is given in ml that contain drug which is in mg is removed or cleared in a unit time which is in minute is called clearance. Clearance is equal to mg into ml per hour. Clearance is dependent on the elimination constant and volume of distribution, which is known as VD. Clearance is sometimes defined as product of elimination constant and volume of distribution, like K into VD. Clearance model. Clearance is mainly calculated from elimination constant, which is K, and volume of distribution, which is VD. So, physiological model of clearance. In this clearance, the drug is based on a specific organ or group of tissue like liver or kidney. So for any organ, clearance depends upon volume of fluid contained, drug concentration, flows or passing through organ, and drug eliminated as such process is calculated as clearance. So clearance in an organ is calculated from blood flow, which is Q to the organ, and extracted ratio of organ, and ER is difference of drug concentration entering into drug Ca, which is Ca, and drug concentration leaving the drug, which is Cv, divided by Ca. So Ca, which is drug entering into the organ, is more than Cv. It means the drug leaving the organ. Er is measurement of fraction of drug removed by organ while drug is passing through the organ. So clearance in an organ is equal to blood flow, which is Q into Er. The formula which is given below.